All right, welcome you guys. So this, we're going to do part one of section 1.1 from the text, okay? So in this section, we're going to talk, at least part one, we're just going to talk about graphing. Then when we get into 1.1 part two, we'll talk about the distance, midpoint, and circles, okay? All right, so we're just basically starting off with the XY plane, or sometimes this is called the Cartesian plane. You can see right here that the Cartesian plane or Cartesian coordinate system is due to Rene Descartes. Okay, so he's the person who we give credit for basically giving a visual to the algebra. Okay, so let's just kind of look at this and talk about it. Now these numbers 1, 2, 3, and 4, so they go counterclockwise. These are the quadrants. Okay, so quadrant one, the reason why this is called quadrant one, because you're probably like, that's so weird. I would have called this one so I could go clockwise or whatever. But this is the quadrant that gets used the most in the real world. Like if you think about you're at a business meeting and you're graphing your graphs at a business meeting, you would probably just say, okay, these are the months, January, February, March, April, May, etc. And this is going to be like our profit. You know, maybe this is like $10,000, you know, 20,000. So you're really just looking at quadrant one there. So we call quadrant one this first one because it's the one where everything's positive and it's the one that gets used most frequently. Okay, and you can see here everything's positive plus plus. Okay, so then you'll just count, you know, around in the counterclockwise fashion. Okay, so in quadrant one, X is positive because we went to the right, and Y is positive because we went up. If we were to pick a point that would be in quadrant two, then you could see that we would move to the left, which is negative, and then we would move up, which is positive. So that's why they have negative positive. So you're always going to be doing the horizontal movement first, you guys, the X movement first, and then the vertical, the Y movement second. So if I have a point down here in quadrant three, I got to move horizontally first. So I'd go to the left, which is negative, and I'd go down, which is negative. So that's why they're both negative there. And then if I pick a point in quadrant four, I do the horizontal movement first. So I'd go to the right, which is positive, and I'd go down, which is negative. So it's alphabetical how we write the ordered pairs. You could see right here, X comes before Y in the alphabet, and we're going to write X before Y when we write an ordered pair. The point right here where you don't move at all, 0, 0, but it's also called the origin. So you might hear somebody say the origin, we'll know that that's going to be 0, 0. So the x-axis is the horizontal axis, and the y-axis is the vertical axis. Now, all of these points that we write out like this, they're called ordered pairs. We'll get into three-dimensional space later in the class where you'll have an x, comma, y, and a z, which will be an ordered triple, okay, instead of an ordered pair. But for right now, we're going to be in 2D space, and so we will just have an ordered pair for now, okay? All right. So let's go ahead and practice some graphing here. So for some of you, this is going to be super easy because you did it, you remember it. For some of you, it's been such a long time that it's dropped out of your brain. You know, everybody's coming into college algebra with a different skill set, a different story, okay? So I'll give you a link to some practice if you're just kind of struggling with this still, okay? All right, so we're going to go to 2, 3. So remember, this is the x, the horizontal, and this is the y. So horizontally, I'm going to go positive 2. So I'm going to go to the right 2. So I'll be right here. And then from there, I'm going to go positive 3. So that's up 1, 2, 3. So I'm going to put the point A right here. This is where point A would be. All right, let's go ahead and do point B. So X and Y. So the X is negative 4. So I'm going to go left 4. And then from there, positive 2. So that would mean go up 2. And that's going to be the point B. Now for C, we're going to go 0. So I'm not going to move in the X direction. But in the Y direction, I'm going to go negative 3. So I'm going to go down 3 spaces. So I should be on the Y axis because the negative 3 is in the Y spot. These are the ones students miss the most when there's a 0. Okay, so just think, okay, it's in the Y spot. I better be on the Y axis. Conversely, for this one here, this negative 3/4 is in the X spot, right? So I should be on the x-axis when I graph my point. So I'm going to go -3/4. Now remember, -3/4 is 0.75. That's why we call it 3/4. If you think about money and you had 3/4, you'd have 75 cents, right? So I'm going to go -0.75. That's not even $1, right? That's not even one. So I'm going to go -0.75, and then I'm not going to go up or down. And that's going to be my spot D. Okay. All right. Another way to think of that, by the way, let me blow this up. If this is 1 right here, really 1 is 4/4, 4 divided by 4. So if you divide up the line into 4 equal spaces, this would be 1/4, negative. This would be 2/4. This would be 3/4. And finally, you'd get to 4/4, which is 1. So you want to put the dot right there. So in my mind, I'm kind of always imagining that there's 4 little spaces when I graph it. All right, that's probably too detailed, but whatever. All right, -√2. It's not like it's something, that everybody just knows, okay? So just go to your calculator and put it in. So now's a good time to talk about calculators, okay? For this class, I have a definite favorite. So the one that I like the most is the Casio 300 FX, I think is what it's called. And it has lots of different ways that it looks, you guys. Like, honestly, any of these up here are going to get you the same thing. I think the one I see most often sold now is this one. It used to be this one was the most sold one. But it's an $11 calculator, and it's amazing, okay? So what's going to happen, let me just blow this up because I think this is the calculator hopefully most of you will purchase, okay? So this is the one I'll talk about when I do stuff in class, okay? Let me snap a picture of this guy so you guys have him. He's in the syllabus too. And let's talk about how to put square root of 2 in it because it's kind of funky. So when you hit square root of 2, right? So you're going to hit you're going to hit the square root button. And then you'll just hit the 2, right? And when you hit equals, it's just going to spit square root of 2 out again. And you're like, what the heck, right? So what you'll need to do is you'll need to use this S to D button. This is how you can get something to turn into a decimal, okay? Like a lot of times when you hit 3 divided by 4 in the calculator, it'll just put 3/4. And you're like, that wasn't helpful, right? But if you hit the S to D button, then it's going to give you the 0.75, okay? So anyhow, if you put it in, so square root of 2 equals, and then you hit the S to D button, it should put out something like 1.41, blah, 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 blah. It's going to be like this long decimal that goes on forever. So we'll just use 1.4-ish, you guys, okay? 1.4 is going to be what we use, okay? All right. So I'm going to go ahead and rewrite this ordered pair as -1.4, -2, x comma y. So since the x is negative, we're going to go to the left 1.4. So like maybe about right here, you guys. And then we're going to go from there down 1, 2, down because it was negative, right? And that's going to be point E. All right, now pi, you probably do know. So pi is about 3.14-ish, right? So we're going to x comma y. We're going to go to the right since it's positive, 3.14. So maybe like right here, you guys. Something like that. And then we'll go down 4 from there. So 1, 2, 3, 4. We should be right here for point F, okay? Now, if this is something that what, people have dyslexic moments a lot on it, especially with these zeros, but to get all the kinks out, I'll put this site in, okay? But I would use, these are kind of fun because you'll know if you're right or wrong when you're done because you'll get a picture. And they're just fun. They make it fun to do it. You do one of these, you're going to get all the kinks out of your system. So I wouldn't do these here because these are only going to be in the positive. You can see here it's got positive and negative numbers. So you could do like the dolphin, the robot, the ladybug. It has a whole bunch of them for you to pick from. Just print that guy out and start graphing just to get it out of your system. So I'm going to go ahead and copy this, put this into the slide. Okay. Oops, I totally did not do that right. Let me try that again. There we go. All right, so it's there for you. Be just a fun way to make sure that you get this graphing down solid if it's something you're struggling with. Oh, it went up here. Sorry, you guys. Go delete this guy out. I can. There we go. Okay. Example 2. Determine whether each ordered pair is a solution of the equation. Okay, so these are actually pretty simple. We know the first coordinate is x and the second coordinate is y. So we're simply going to substitute for the x and the y in the equation. So let's see here. We have 2, and instead of x, we're going to put -5. And instead of y, we're going to put 7. And we're going to check to see, it says determine whether each ordered pair is a solution. Okay, so 2 times -5 is -10. 3 times 7 is 21. And we want to know, question mark, does that equal 6? Well, -10 plus 21, that's 11. And that does not equal 6. So the conclusion is that -5, 7 is not a solution. Okay. All right, let's check over here. So we're going to go ahead and substitute 2 in for the x and 10/3 for the y. I'm just going to keep doing decimals and fractions because I know that's what we struggle with, which means that's what we should be doing most often. So I'll always try to pick some equations that have decimals and fractions. All right, 2 times -2 is -4. And here we can cross cancel the 3's. So that's going to just leave us with a 10. And -4 plus 10 is 6. So in this case, it is a solution. Okay, so we're going to go ahead and say, and it probably won't let me type it very well. I'll type it like this: -2, comma, 10/3 is a solution to the equation. Yeah. So there's lots of ways to graph these, you guys, so many. But what we're going to start off with at first is just using intercepts. So let's make sure that you know what an intercept is. So if I have a graph and I have some line, say it looks like this. And let's say that let's see, 1, 2, 3, that's going to be 4. And then we'll say this is 2. Okay. This dot right here, since it crosses the x-axis, that's going to be your x-intercept. And what you'll notice is the ordered pair, if you're on the x-axis, will always have 0 for the y. Because think about it, we went right 4, but then we didn't go up or down at all. So that's why the y component is always going to be 0 if I'm on the x-axis, okay? All right, now, over here on this spot right here, this is going to be called the y-intercept. Because that's where we cross the y-axis. And similarly, one of the coordinates is going to be 0, but this time it's going to be the x-coordinate that's 0 because we didn't move horizontally. We didn't go left or right, so we didn't move in the x direction. We only went up 2, so we only moved in the y direction. So the takeaway here that I want you to remember is if we're on the y-axis, x is 0. If we're on the x-axis, y is 0. It's kind of like opposites. So that's what this next, oh, I guess, did I not print it? Give me a second, you guys. I guess I did not print it. So let me just grab this because this is the most important thing. Okay. That's what this slide is saying right here, or this little box, okay? It's saying an x-intercept is the point a comma 0. To find a, let y be 0. So for x-intercepts, let y be 0. For y-intercepts, let x be 0. And that makes complete sense given what we see here in this picture. Okay, so that's how we're going to graph, at least in this section. We'll come up with other ways of graphing, but for right now, that's what the text wants us to do. Okay, all right. So we said to find x-intercepts, we let y be 0. And then we said to find y-intercepts, we let x be 0. Okay, so I'm going to go ahead and start by letting y be 0. All right, so we got 2x, and 3 times 0 is 0. And 2x plus 0 is still just going to be 2x because we didn't add anything to it. Now, to get rid of the 2, since the 2 is multiplying, the opposite of multiplying is dividing. And that's what's going to get us the x by itself. 2 divided by 2 is 1, but we don't write the 1, you guys. There's always a 1 there we don't write. And 6 divided by 2 is 3. So the x-intercept is going to be 3, and don't forget we let y be 0. So that'll be the point right here. All right. Let's do the same thing, but this time we're going to let x be 0. So 2 times 0 is 0. 0 plus 3y is just 3y. And to get rid of the 3 that's multiplying, the opposite of multiplying is dividing. 3 divided by 3 is 1 that we're not going to write. And 6 divided by 3 is 2. So the y value is 2, and don't forget, we let x be 0. Now, as long as you have 2 points, you know exactly what line it is. There's only one line that can go through 2 points. So that is going to be this line right here. So you can use intercepts to find the graph of a line. Now, one thing I want you to notice is when you plug 0 in, it basically makes that part go away. So let's give you a shortcut. If I'm letting y be 0, then I can essentially just write down this equation because the whole y part is gone. You'll notice that that matches this equation right here, 2x equals 6. That's what I have left, 2x equals 6. Similarly, if I had done the second part where I let x be 0, you can just cross off the x part, and you'll see that you have 3y equals 6, which was all the way down here, so it'll save us so much time. So I used to, when I had a whiteboard and I had these equations, I would just cover it with my hand. I'd be like, okay, guys, solve that equation. And then when they were done, I'd cover this part with my hand and say, solve that equation. So that's going to be a really quick way for you to be able to get the intercepts. Okay. Now, a really important skill for the whole class, honestly, and classes beyond, is being able to solve for y. So I'll go through this one example here, but I'll give you a site that shows you how to, or gives you a worksheet to practice more. It has the answers, and I'll try to make a video of me solving them so you can check yourself, because you just need to be good at this. Like, I'll let you know when there's things that are like super important. It's like, guys, you better be good at this, okay? All right, so solving for y. All right, so basically you want to get the y by itself. The goal is in the end to have y equals something. So you're going to have to start moving stuff. This 3x is going to have to go. This -2 is going to have to go, right? We're going to have to rip all that stuff away, okay? So we'll start by moving the 3x over to the other side. Now, anytime that you move something across the equal sign, its sign has to change, okay? So this will no longer be a positive 3x. When we put it on the other side, it's going to have to be a negative 3x. Now let's talk about that. I'm giving you my shortcut, but let me kind of show you, what the math is that makes that happen. Really what you're doing is opposites again. Remember on the last slide, it's like, oh, I'm multiplying, so that means I need to divide. Well, this is a positive 3x, so to get rid of it, I'm going to have to subtract 3x. Because 3x minus 3x is a big fat nothing. So it's gone now, it's 0, okay? And you'd bring down your -2y. And we can't combine these because they're not like terms. A lot of students try to. If they both had x's, sure, go for it. But since one of them has an x and one doesn't, we just rewrite it, you guys. We can't actually combine them, okay? So that's like what's really happening. Why, when this 3 goes over to the other side, it ends up being a -3. It's because we subtracted it away. All right, and then we want to get rid of that -2. Now notice that -2 is multiplying by the y because it's right next to it with no sign. No sign means multiply, you guys. So to get rid of it, we're going to divide by -2 to everybody. So we end up getting y equals, and you got to clean up your signs, you guys. 2 negatives are going to make it +3/2. A negative divided by a negative equals a positive. Same thing here. 2 negatives are going to make it a positive. And 8 divided by 2 is 4. So there's our equation. Oops, solved for y. Sorry, it's layering here, you guys. I just want to move this out of the way to give us some space for doing some math here. Okay, there we go. Okay, so now we've solved for y. Now what we want to do is we want to get some ordered pairs so we can graph this. Now when you're picking, let me talk about some good ways to pick stuff, okay? I can see that there's a 2 in the denominator here. That makes me want to pick evens. Let me really quickly show you why I'd want to pick evens. Let's say I don't pick evens and I pick like a 1, because 1 might be something I would pick, you know? If I just choose a 1, 1 times 3/2 gives me 3/2 still. And now I'm forcing myself to work with fractions, which isn't terrible. You have the Casio 300 or whatever calculator, right? You can make that work. But keep in mind, you're going to have to graph fractions too. So I'm not really digging that choice, okay? So what I'm saying is I think some good choices would be some evens. So I might pick -2. I always like 0 and +2 to start with, okay? So let's go ahead and do those. So this is going to be x equals -2. This will be x equals 0. And this will be x equals +2. Okay. All right, so I'm going to substitute -2 in for the x. Okay, so now why is that a good choice? Well, these 2's can cross cancel, right? But keep in mind, there's still a negative here, right? So this isn't going to be +3. This is going to be -3. I mean, another way you can do that, I'm giving you tricks, you guys, which I think make it easy, but technically, I'll show you this, one time here. Technically, you're supposed to put a 1 underneath and just multiply straight across. So you'd get -6 over 2, and that's division, right? So 6 divided by 2 is 3, and that's why it ends up becoming -3. A negative divided by a positive equals a negative. So this little trick of crossing off the 2's makes it, I think, expedited, makes it a lot quicker, and we'll use it a lot in the class, okay? All right, so -3 plus 4 is going to be 1. If you're one of those people who struggles with positives and negatives, don't worry about it. You are allowed the calculator for your tests and your homework and stuff. So just put it in. I'm not going to know, okay? All right, so 1's the y value. So -2, 1, -2, 1 is going to be this one. I'm actually going to try to use different colors so you know which points, you guys. Oops. So let's go ahead and do 0 now. All right, so we got y equals 3/2 times 0 plus 4. Well, 0 times anything is 0, and 0 plus 4 is just 4. So 0, 4 is going to be the ordered pair. Now remember, 0, 4, the 4 is in the y spot, so make sure you're on the y-axis when you graph it. Now shortcut, 0 is going to annihilate anything. So as soon as you see 0 times something, you could just be like, he's gone. There's my 4. Okay. All right, let's go with this last 2. So it's going to be y equals 3 over 2 times 2 plus 4. And we know that those 2's are going to cancel. One's in the top, one's in the bottom. So we just get y equals 3 plus 4. So we get y equals 7. All right, so this is going to be the ordered pair 2, 7. Now 7's off the grid. I could kind of continue it. Let's see here. It looks like this would be about 5, this would be about 6, and this would be about 7, like up there maybe. And then I would just go and graph my line. So let me go ahead and do it in black. There's my line, kind of, sort of. Rotate it a little bit. And I'm going to move this dot. I think it was off. Oops. I think it was off a little bit. There we go. It didn't quite get to 7. Okay. All right. There's arrows on the end because these go on forever. Now, something I want to point out that I didn't, let me go back. This was the exact same equation from example 2. 2x plus 3y equals 6. 2x plus 3y equals 6. Okay. Now remember, negative 5, 7 didn't work. Well, let's go check. If you look at negative 5, 7, here's negative 5 over here. And 7 would be like, let's say this line keeps going. 7 would be too high. Okay, I kind of need to shrink this a little bit. Okay. Let's say 5, 6, 7. So negative 5, 7 would be like right here, you guys. That wouldn't be on the graph. It'd miss it, right? So that's why it wasn't a solution. But if you go back, we said negative 2 and 10/3 was. So negative 2 and 10/3, by the way, negative 2 and 10/3 is really negative 2 and like 3.33333333. Okay. So if I go to negative 2 up 1, 2, 3.33, wow, there I am. I land right on the graph, right? So what we're doing here is all of these points that are on this line are actually solutions to this equation. If you picked any one of them and you plugged them in, they would work. Okay. And there's infinitely many x comma y combinations that will satisfy this equation. So when we're graphing, we're actually graphing them and saying, here's all the solutions. Okay. So hopefully that helps. Okay, this is our last one, you guys, example 5, or at least for part 1. Now we're going to get into graphing parabolas later on in the class. So for right now, we're just going to t-chart it. Okay, and I've strategically picked these values because I kind of, know good ones to pick. But let's say that you pick some values and you get something like this, and you're just like not quite sure how to graph it, plug in more values. You'll start to see maybe that it turns. And then you're like, oh, okay, I think I see what this looks like now, So when it comes to picking the x's, if you can't quite see it, just plug in more, you guys. Okay, that'd be my advice. All right, so I'm going to go ahead and substitute all of these in and do the math. Okay, so we're going to substitute in x equals 0. We're going to substitute in x equals 1. X equals 2. X equals 3. And our last one will be x equals 4. I'm trying to think of a color I haven't really used. Okay. All right, so let's start by plugging in 0 into the equation. So y equals 0 squared minus 4 times 0 plus 1. So that's going to be y equals 0 minus 0 plus 1. So that's going to be y equals 1. So it looks like 0, 1 is going to be on the equation. Sorry, guys, let me move these down a bit and give myself enough space. Oops. Better write a little smaller next time. Okay. All right. Oops. Bring this guy back. All right. So now we're going to pick x equals 1 and plug that in. So y equals 1 squared minus 4 times 1 plus 1. So we're going to get 1 minus 4 plus 1, which is negative 3 plus 1. And so that's going to get us, I'm just going to come up here, you guys, negative 2. All right, so we got 1 negative 2. All right, now let's plug in 2. Y equals 2 squared minus 4 times 2 plus 1. Y equals 4 minus 8 plus 1. Y equals negative 4 plus 1. So it looks like y equals negative 3. So we got 2 comma negative 3. I should have been graphing these as we go along, huh? 2 to the right, negative 3 down. For the blue one, 1 to the right, negative 2 down. For the black one, 0, 1, so 1 in the on the y-axis. All right, let's move into the red now. All right, so we've got y equals 3 squared minus 4 times 3 plus 1. 3 times 3 equals 9. 9 minus 12 equals negative 3. So we get y equals negative 2. So 3 comma negative 2. So over 3 down 2. And we see the turn, right? Okay. All right, last one, you guys. So x equals 4. So we've got y equals 4 squared minus 4 times 4 plus 1. 4 times 4 is 16. 4 times 4 is 16. So 16 minus 16 is just going to cancel out. And we're just left with y equals 1. So 4 comma 1. So over 4, and now it's positive 1, so up 1. And I think we can see, what's happening here. It looks like we have what is called a parabola. Oops. Sorry, you guys. There we go. All right, you guys. So that's part 1 of 1-1, and I'll make another video for part 2. Hey there, you guys. So on example 4 in the notes, we did this solving for y where we moved the 3x over and then we divided everybody by negative 2. And I said, that's a super important skill. So I said I'd give you some resources if you, need some practice with it. So I have this website. I went looking through a lot of them and finally found this teacher who, let me go and see if I can find it. Yeah, here it is. Has a YouTube video, which I think he does an excellent job of solving in it. Then he has this downloadable packet that you can do. It's got solutions, and then it's got more that you can practice, okay? So that's available for you. I think he does an excellent job of solving them in the way that we're going to solve them in this class, and in the way that I think is the best way to solve it too, with plenty of examples. So if that's a skill that you need more work on, you guys, I have saved it in the note file for you in case you want to practice that. All right, take care, you guys.